Alright, so I just realized I completely messed up the video making this. I'm still probably going to upload it, but this window with my actual code is supposed to be the foreground for like half of it, but it wasn't. It was in the corner, and you cannot read the corner very well. So, yeah, I'm just going to go over what we did while you can actually see it. So, I'm going to start with the runner class, which is what's actually ran. We make a new keyboard scanner to scan for inputs, and we make a bool that's set to true by default, and this determines if we want to keep playing again or not. So while the bool is true, so default this will run, we want to ask how many numbers, which we got from the sample outputs, and then int upper bound equals scan.nextInt, so we get the number for this question, and then we do the next line to pick up the white space, which is what I figured out whenever we went back to the notes in the last video. And then we instantiate a new class of guessing game called game with the upper bound that we set, and then we play the game and print out the results, and then we just ask, do you want to play again? And if the answer contains y, so if it's yes, or if it's y, or any uppercase, because we automatically set it's a lowercase, then play again remains true. If it doesn't contain y, then it's false. So this just completely ends. Now time to go to these three lines and explain those. Whenever guessing game is first instantiated with the upper bound, it sets the class's upper bound to the one we inputted. So this dot upper bound says this class, look in this class instead of this scope, and look for a variable named upper bound, so it goes to this one instead of this one, and we set it to that. And I made this final, which means upper bound will not be touched unless it's in a constructor. By touched, I mean modified. As you can see, every time we call it, we're not modifying it, we're just reading it. And then we have these two variables because they're needed to be called in toString. We'll get to that later. So the next thing we call is play game. After instantiating that, and in play game, we set the conf choice. So this computer choice, the classes. So always think of this is class. This class dot conf choice. So this class is computer choice equals, and we're gonna ignore this int for now, math.random, so that chooses a random number between 0 and 1, and we multiply that by upper bound minus 1, because this minus 1 is here. Okay, so we have upper bound, so it's multiplied from 0 to 1 to 0 to the upper bound. So in this case it would be 5, but we do minus 1 because we're adding 1 to it at the very end. Since we don't want the first one to be 0, we want the first one to be 1. So that gets us 1 to our upper bound. And we cast it to an int because we don't want variables to have a metissa, or we don't want them to be a double. A metissa, if you didn't know, is like, well, that's not even a number. This is the metissa. Everything that comes after decimal. So then we make a new scanner for keyboard input, and a variable for user guess, which is named -1, because it needs to be something, but -1 will always be impossible. And we set this class num guesses, which is how many times we've guessed, to 0. So now we have a do while loop, and a do while loop checks the condition after it's run. So this will run, it'll print out and ask enter a number between 1 and the upper bound. We give them that number, and let's see, while user guesses, so we give them that number, and then because we're not going for a string, it's just integers, we don't need to do the white space thing that we did here with next line. You can if you want to, but you don't have to. Now this while loop inside the do while loop just checks to see if the guess is in the range, so if it's less than 1 or if it's greater than the upper bound. So if it's less than the lower bound or greater than the upper bound, we print out that it's out of range and we force them to input a new number. And then after that's finished, we just increment num guesses, the class's num guess, by 1. And this all happens while user guess does not equal this class's computer choice. So that gets checked at the very end, and then we just print the line because the sample output had a break there. Now, very last thing is toString right here. Whenever the object gets put to a string, we print out it took num guesses, so how many guesses it took to guess the number of the number that was the guess. So it took like 4 guesses to guess the number 9 or whatever. We're using this on everything because this class is variables. I'm going to keep saying that, and hopefully you understand what I mean, because Mr. Guider did not understand what I meant whenever I said that the first time. And then this is just a percent calculations. So to get the percent of how wrong we were most of the time, we're going to take 1 and we're going to put it over the number of guesses and then multiply it by 100. So that is the percent of 1 out of the number of guesses. So 1 time out of all of them is that percent. We cast it to an int because the sample output didn't have a metiso. And then we do 100 minus it because it's a percent, and we don't want one of them, we want all but 1 to see how wrong we were. If it was guessed right, you guessed right, then we would not do the 100, but it's wrong. So, yep, that's it. Let me know if you have any questions.